Alright, hey y'all, it's Miss Summers with your notes about layers of the atmosphere. So we want to know how the different layers are different from one another. How do we tell when we gone from one layer to the next, so on and so forth. Alright. So if we were at school, this would have been our warm-up. Why is the atmosphere important to you? The atmosphere, remember, is that layer around the Earth of gases. It protects us from space. It serves us it serves a lot of functions. So we definitely want to know what it's made of and its composition. All right, so let's start with what it is. All right, so it's made out of air, it's made out of gases. The majority of our atmosphere is actually nitrogen, which is N2. Nitrogen is what's called an inert gas. It doesn't like to do anything. It just kind of hangs out, which is really good. It means it's not chemically reactive. It doesn't like randomly explode, which is kind of awesome. And the other 21% is oxygen, which is really important because that's what we breathe. That's what we breathe, and we use oxygen to turn food into energy. So, like, it's kind of nice that that's there. This other 1% of other are other gases like argon and carbon dioxide. Carbon dioxide is going to be a really big deal when we start talking about climate, and a variety of other gases. All right. Other things that you might see in our atmosphere in very small substances are things like water vapor, ozone, salt, smoke, pollen, especially now in springtime, and ash and dust from volcanoes. Okay, even though these are very small portions of the atmosphere, they can affect living things quite a bit. All right. So humans impact our atmosphere. We haven't talked about human impact yet, but we will after not this unit, but the unit after that. It'll be one of our last units together. We impact our atmosphere by adding things to it, like emissions from vehicles, sulfur dioxide from factories, and that affects the products that come out of our atmosphere. It makes things like acid rain. Hey, JJ. All right. Before we get to the layers, let's just talk about ozone right quick. We will talk about ozone when we get to the stratosphere here in just a few minutes. Ozone is a gas that protects us from UV radiation. All right. And it's actually not good to breathe in, like down here at the ground. But in the stratosphere, which is above the Earth's surface, it protects us from UV radiation. All right. Ozone, whoops, too far. I don't expect you to like be able to like write these down from memory. Just know that ozone is made out of 3 oxygen atoms. Energy from the sun will split apart. Oxygen normally likes to be with itself. It likes to like hold hands with another oxygen, but the energy from the sun will break it apart. And now that lonely oxygen is like freaking out because he doesn't have anybody to hold hands with, so he'll go and latch onto an O2 molecule, and that's O3, and we call O3 ozone. All right. We affect ozone with our CFCs. We will get to that later in the next couple units. Just know that CFCs, chlorofluorocarbons, we'll talk about what that is later, break down ozone. Chlorofluorocarbons break down ozone. All right. Now here's where we actually start. Here's like what I want you to learn today. Layers of the atmosphere. All right, so the atmosphere goes up starting from the surface of the Earth and thins out gradually. There's no actual like line that we've definitively said like, okay, you've now left Earth. Welcome to space. There's not really a clear boundary. All right. We have 4 main layers. We're going to start, when we learn them, I want you to learn them from the ground up. Just like if we were like in a balloon, we're going from the ground upwards. So remember that. All right. As we increase in altitude, all right, we're looking at these layers and their various altitudes. What happens with said altitude and pressure? Pressure is going to decrease, and we're going to talk about air pressure later on in this unit as well. Pressure is just how much the air weighs. All right, so the closer to the ground you are, the higher the pressure is. The further up you go, the less and less it gets. So that's an inverse relationship. All right. So as pressure changes, that also affects temperature. And when we're looking at these layers, the layers are based upon how temperature changes in each one. All right, so the layers are based on temperature. So write that down. I'm going to say it one more time. The layers of the atmosphere are based on temperature changes. All right, let's start in our first layer, the troposphere. All right, so this is the layer that is closest to Earth. In the troposphere, temperature decreases as altitude increases. Okay, so basically as you go up in the troposphere, it gets colder, which makes sense. All right, think about the highest place you can be on Earth. That would be Mount Everest. Okay, as you go up the mountain, it gets colder. Yay. All right, the troposphere is where weather occurs. All right, is because air is constantly moving around because the cold air wants to sink and the warm air wants to rise. It has a general thickness of 7.5 miles. I don't expect you to memorize that. And temperature goes from about 70 degrees on the surface to about -70 at its very coldest. Okay, again, I don't need you to memorize the exact temperature. I just want you to know it gets colder as you go up in the troposphere. Our next layer is the stratosphere. The stratosphere starts at about 12.5 miles up and goes to about 30 miles up. And here, the temperature rises as you go up in altitude. So it's the exact opposite. It gets from about -70 degrees at the bottom of the stratosphere. And as you go up, it increases about 100 degrees. And this little baby penguin's like, Mom, why did the temperature go up in the stratosphere? It has to do with the ozone layer. So remember the ozone, that layer that protects us from ultraviolet radiation? The ozone is absorbing that radiation and that heats it up. All right, so pretend you're in a hot air balloon right now. We go up in the troposphere. All right, it got colder as we go up. And then all of a sudden, when we hit the stratosphere, we're continuing to go up, but the temperature is now getting warmer. It gets warmer in the stratosphere. All right, we see our little diagram here. Troposphere is down here, stratosphere is here. Weather's at the bottom. All right, our next one, the mesosphere. Meso means middle because technically there's 5 layers, but we don't talk about the exosphere, so just ignore that. In the mesosphere, temperature decreases as altitude increases. So it's like the troposphere. It's similar. All right, it goes from about 30 miles to 50 miles up. Again, I don't need you to memorize the exact temperature ranges nor the thickness. I just want you to know this shenanigans. Temperature decreases as altitude increases. In this layer is actually kind of important because it protects us from thingies in outer space. In the mesosphere, you might see this right here. You're like, oh, it looks like a shooting star. It is. What a shooting star is a meteorite or a piece of rock from outer space that is hurtling down towards the Earth. All right. Most of these rocks burn up in the mesosphere, so it protects us, which is kind of cool. All right. And our last layer, the thermosphere. The thermosphere, thermo means heat. So in this layer, it gets warmer as you go up, just like in the stratosphere. But here, the thermosphere is getting warmer because it is directly absorbing solar radiation. It goes from about 50 miles up to about 100 or so miles. Again, I don't need you to know the exact range per se, but it gets really hot, okay? There's not a lot of molecules in the thermosphere. The molecules are really spread apart, but because they're getting hit directly with solar radiation, they move around really fast, and that's why it's warmer. The thermosphere is where the International Space Station orbits. It's also home of these things. You might have seen pictures of these. If you're lucky enough to see them in real life, that's super cool too. These are the auroras, or the northern lights, or the southern lights, depending on what hemisphere you're in. This happens in the thermosphere where the Earth's magnetic field is weaker, like at the North Pole and the South Pole. And basically, radiation from outer space is hitting these molecules and getting them so excited they start to glow these different colors. All right, so that is our 4 main layers of the atmosphere. Just to recall, we have the troposphere, which gets colder as you go up. We have the stratosphere, which gets warmer as you go up. We have the mesosphere, which again gets colder as you go up. And the thermosphere gets warmer as you go up. All right, you're going to want to remember the order of these. Okay, I would expect you to know that. We came up with a little mnemonic device a couple years ago that I really liked to remember the order, and it was tropical starfish makes tacos. All right, I like that because the first word was tropical, which was tropo, which doesn't get me confused with thermo up here. All right, so just know it goes colder, warmer, colder, warmer. All right, know why these 2 layers, the stratosphere and the thermosphere, get warmer. Because this one gets warm because of the ozone layer. Thermosphere gets warm because of the direct radiation. Know that the troposphere and the mesosphere get colder. Troposphere is where weather happens, and it's where we live. All right? You have no assignment for this particular day, so if you want to go ahead and jump to the next day, that's totally cool. If you have any questions, you just let me know.